Dear students, today we will discuss illustrating and describing mathematical systems with axiomatic structure. In this lesson, you will learn to describe mathematical system, identify the different axiomatic structure of a mathematical system, define terms or undefined terms, axioms, postulates, and theorems, illustrate mathematical systems, and illustrate a mathematical system following axiomatic structure. So in lesson 1, we will discuss describing mathematical system. So God has given us bountiful nature with different shapes and measurements that are connected with geometry. Shapes like circles, rectangles, squares, and triangles are some examples that can be found in our cars, roads, bridges, and buildings, or other sources that are available around us. To be able to know, understand, and value this, it is important to have basic knowledge and concepts of geometry. In this lesson, you will enumerate the components of mathematical system and begin to describe them as you move further with the lesson. So what is geometry? Geometry is the measurement of earthly objects. It started as a way of calculating land measurement, particularly in Egypt and Babylon, where it got its name geo, which means earth, and meter in, which means to measure. But Euclid gave geometry a new definition and developed it into a formal study of statements that involve reasoning. He then defined geometry as the study of body of logically connected statements. This makes completely clear that in geometry, a statement leads to another statement in an arrangement that is supported by reasons. In the mathematical system designed by Euclid, there are 4 parts, namely undefined terms, defined terms, axioms and postulates, and theorems. So what is undefined terms? There are terms which cannot be defined but can be described. This is what we call undefined terms. So remember, undefined terms cannot be defined but can be described. Undefined terms in geometry are points, lines, and planes, which are said to be the building blocks of geometry. So let us examine this description and real-life examples. So point is a figure with no length and width, or simply with no dimension. This one, a point is a name by a capital letter, so the point is read as point B. So in real life, we have an example of tip of a pen. So this is what we call point. Another example of undefined terms, line. A line has no width and no thickness, but it can be extended infinitely in opposite direction. A line is determined by locating 2 points on the line, and it is named with a lowercase letter or 2 capital letters with a double arrowhead above it, and the figure below is read as a line BC or line M, denoted by line BC. Crease of a paper, it is an example of a line. Another example of undefined terms, a plane. A plane is a flat surface that extends infinitely in all directions. A plane is named with a capital letter. The plane is named as plane N. It is what called plane N. It is read by plane N. A cover of a book, it's also a example of plane. Let us proceed now to define terms. In geometry, defined terms are terms that have a proper definition and can be defined by means of other geometrical terms. The basic defined terms in geometry are lines, segments, rays, opposite rays, and angles. So, This is a line segment. A line segment is formed when two distinct points are connected with a straight line. This is a representation of line segment. A line segment is determined by locating two points and it is named with two capital letters. The figure below read as line segment AB or denoted as BA or AB. A ruler is also an example in real life of a line segment. Ray. A ray is a part of a light. It extends infinitely in one direction only and stopped by an end point by a point on one end. A ray is determined by locating 2 points. It is named with 2 capital letters with a single arrowhead above it. The figure is read as ray AB or AB and denoted as may arrowhead above AB. Ray AB. Arrow is an example of ray. Angles. An angle is a figure formed by 2 rays meeting at a common end point. Angles are denoted by a number, vertex, and the 3 capital letters. The angle below can be named as angle XOY or angle O or angle 1. Hands of a clock is also an example in real life. Here are some common terms that you may encounter along with undefined terms. Midpoint of a segment is a point that divides the 2 segments into congruent segments. In the figure, we let N be a point AB. Point N is called the midpoint of AB. If AN is congruent to NB, congruent means having equal measure and similar shape. To denote congruency, we use this one. This is what we call congruence. Therefore, we can write AN is congruent to NB. Next, congruent angles. Angles having equal measure. Congruent angles having equal measure. So, since the 2 right angles have a measure of 90 degrees, therefore, angle AXB is congruent to angle CYD. Remember, congruent, it is a meaning equal. Equal shape, equal yung measure, equal yung shape, or similar shape. Next, bisector of an angle. A ray that divides an angle into 2 congruent or equal angles. If point Y lies in the interior of angle BCD and angle BCY is congruent to angle YCD. Then, angle BCD is bisect by line CY or ray CY is called the bisector of angle BCD. Perpendicular lines. Perpendicular lines formed when 2 lines intersect with each other and form right angles. The perpendicular sign is this one. It is used to show that 2 lines are perpendicular. In the figure, line AC and line BD intersect at point F to form right angles. To denote perpendicular, we use this sign. Therefore, we say that line AC is perpendicular to line BD. And since angle AFB and angle CFB form a linear pair, then they are supplementary. Since perpendicular lines form 4 right angles, therefore, angle AFB, angle CFB, angle CFD, angle AFD, the measure of this is 90 degree. Let us proceed to properties of equality. Reflexive property, a number is equal to itself. So for example, that is A is equal to A. So by reflexive property, BX, line BX is congruent to line BX. In symmetric property, if A is equal to B, then B is equal to A. So, by symmetric property, if ABC is congruent to CDE, then angle CDE is congruent to angle ABC. Transitive property, if A is equal to B, B is equal to C, then A is equal to C. By transitive property, if line AB is congruent to line CD, and line CD is congruent to line EF, so therefore then line AB is congruent to line EF. Did you get it? Okay, proceed. Let us proceed to axioms and postulates. Axioms and postulates are both statements that are assumed to be true without any proof. Their only difference is that axioms are used in other areas of mathematics, while postulates are widely used in geometry. Listed below are some of the postulates which are used as guiding rules, as assumption from which other statements on the undefined terms can be derived. Remember that these statements are already accepted as true statements. So, the line postulates, there are 2 points contained in exactly one line. This is an example of postulate number 1. Postulate number 2, a line contains infinitely many points. Infinitely many points. Postulate number 3, if 2 points of a line lie in a plane, then the line lies in the same plane. The plane postulates any 3 points lie in at least one plane and any 3 non-collinear points lie in exactly one plane. Here's an example of postulate number 4. Postulate number 5. If 2 different planes intersect, their intersection is a line. In the figure below, plane E and plane G intersect at line CD. Postulate number 6. The angle measurements postulate. The measure of an angle is a real number between 0 degree and 180 degree. So, measure of EFG is equal to n and 0 degree and 180 degree. Postulate number 7, linear pair postulates. If 2 angles form a linear pair, then they are supplementary. Therefore, angle AYC and angle BYC are linear pair. Parallel postulates. Given a line and a point not on the line, there is exactly one line. Through the point is parallel to the given line. Therefore, M is parallel to N. If 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. In the figure, angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 4 is congruent to angle 8. And angle 3 is congruent to angle 7. Let us proceed to theorem. A theorem is a basic geometric principle which are proven to be true by making connections between accepted definitions, postulates, mathematical operations, and previously proven theorems. All right angles are congruent since AXB and angle CYD are both right angles. So therefore, angle AXB is congruent to angle CYD. Vertical angles are congruent. In this figure, angle ABC is congruent to angle FBD, and angle ABD is congruent to angle FBC. If two parallel lines are cut by transversal, then the alternate interior and alternate exterior angles are congruent. So example of alternate interior angles, angle 3, this is a alternate interior angle. So therefore, angle 3 is congruent to angle 5, angle 4 is congruent to angle 6. Let us proceed to alternate exterior angles. So nasa labas. So angle 1 is congruent to angle 7, angle 2 is congruent to angle 8. If two parallel lines are cut by transversal, then the interior angles on the same side of the transversal are supplementary. In the figure, the pair of interior angles on the same side of the transversal are angle B and angle 6, angle 4 and angle 5. Therefore, angle 3 and angle 6 are 180 degree. And angle 4 and angle 5 is also a 180 degree. Angle 4, angle 5 is 180 degree. If two parallel lines are cut by transversal, then the exterior angles on the same side of the transversal are supplementary. In the figure, the pairs of exterior angles on the same side of the transversal are angle 1, angle 8, angle 2, and angle 7. Therefore, angle 1 and angle 8 is 180 degree, and angle 2 and angle 7 is also 180 degree. Let's see this illustration. So according to angle 1 plus angle 8, when we add these two angles is also 180 degree, and angle 2 plus angle 7, this is what we did when we add this angle 2 and angle 7, so also the measurement is 180 degree. Let's have an activity. Fill me in complete the crosswords puzzle by identifying the words being described. Write your answer on separate sheet of paper. This is your answer.